Welcome and good morning, everyone, to NSDF's Environmental Assessment Follow-Up Monitoring Program presentation and question and engagement session. I would first like to start off by acknowledging the Algonquin Nation, whose traditional and unceded territory most of us, not sure everyone, are gathered upon today, and certainly the NSDF project takes place in this territory as well. So for the agenda today, we're going to start off with some introductions and the welcome. We're going to move to Christine Gallagher, who's going to provide us a presentation on the environmental verification and monitoring program for the NSDF. And then also, as we're working through that, some chances for questions and answers, as well as towards the end, some engagement on the questions and answers as well. So I'll introduce myself first. I'm Mitch McKay. I'm the manager of stakeholder relations for environmental remediation management's team of communications professionals. We work on many of the projects related to the restoration and environmental cleanup of the Chalk River site, but also sites that CNL is working on across Canada. Many of those projects you may have engaged with us before on, and we're always happy to take questions on those other projects we're working on, and always available to engage as well. And we hope that you've taken advantage of our mailing lists to keep informed on developments across the CNL portfolio of environmental restoration projects. But today we're focused on the Effluent Verification Monitoring Program, and I'll let Christine Gallagher introduce herself, and then I'll work through the list of other colleagues that have joined her.
Yeah, good morning, everybody. My name is Christine Gallagher. I'm the section head of the Environmental Protection Program here at CNL. So I'll be presenting most of the stuff today. I'll let Mitch introduce the rest of the team.
All right. We also have Sandra Fott with us today.
Good morning, everyone. I'm Sandra Fott, and I am the manager of licensing support.
We have Carla DeWall joining us today.
Good morning. I'm Carla DeWall. So I'm section head of monitoring programs at the Chalk River site.
I have Martin Klukas joining us today.
Good morning. My name is Martin Klukas, and I'm an environmental specialist with the Environmental Protection Program and have supported the NSDF for a number of years.
I have Reza San Pedro.
Good morning, everyone. My name is Reza San Pedro. I am an environmental analyst. I've also been supporting the NSDF during the EAFNP development. Thank you.
And we also have John DeWald joining us today.
Hi, John DeWild from Golder Associates. We're the contractor that worked alongside CNL in developing this effluent monitoring plan.
All right. Thank you, everyone, for your introductions. And we hope that through all the expertise we have on the line today, we're able to answer most of your questions within the scope of this Effluent Verification Monitoring Program. So I'm just going to go through a bit of the logistics today so everyone's on the same page. Obviously, due to the ongoing pandemic, we've moved these technical discussions to the virtual world. I know that previously we have done these in person, so we're now moving them into the virtual so that everyone comfortable, can participate in these. The format today is a presentation with a few pauses for questions and engagement, and then we will, towards the end, open it up to a more fulsome question and answer period. Christine will be presenting today, and if there are questions that are out of her area of expertise, as we just introduced, we'll try to get the right person to answer the question. But if it's completely out of the scope of the topic today, we'll have to get back to you with an answer at a later time. As we're going through the presentation, please, out of courtesy to the presenter and others, keep yourself muted. If you'd like to talk, just raise your hand and I'll work to fit you in and call on you to unmute and ask us the question. Today we are going to try, because it's a much smaller group and we do want to try some good Q&A and interaction. We're going to try to avoid the typing question. We much prefer you ask your question and then we can answer. If it's not possible, of course, please do type in your question. But if you are comfortable and you have the ability to, please do ask your question via the mic, and that's much appreciated. As with all of our previous webinars we've been doing, simultaneous translation is available for this technical briefing. You can access it through the globe icon on the bottom right on the bar on the Zoom platform there. You select the language you'd like to hear, and you can toggle between the French and English. There is, because we are doing this in English, there is a slight lag on the French translation. So please wait for the full translation to come through before you do ask your question. And then to help out the translators, please speak clearly and slowly so that they can translate your question. If you have a headset, it would help out, but if not, just try to speak into your mic as clearly as possible. Finally, this session is being recorded, and I think will be made available at some point on our YouTube page for others to watch, and also available for us to be able to go back and take notes and make sure that we captured everything correctly. Okay, with that, I will turn this over to Christine to begin the presentation. Christine.
Great, thank you, Mitch. Can everybody hear me okay before I go? Nodding. Mitch, yes, you can hear. All right, good. So thank you, welcome. And before I get into the talk about the Effluent monitoring program, or the EAFMP, I just wanted to give a little brief overview of NSDF. Now, we're kind of going under the assumption that people joining today have some knowledge of what is happening with NSDF. So there isn't a lot of content in here about the actual project itself. It's just more about the follow-up program. But just to remind folks of what we're doing, I'm just going to give a little bit of a quick tour. So, this here is the rendering of the NSDF site, the Near Surface Disposal Facility, for those who aren't familiar with that acronym. We have here in the center is the Engineered Containment Mound, also called the ECM, and that is where the waste will be placed. It's going to be developed in 2 phases, so there'll be a phase 1 and a phase 2, and then each phase is actually divided into cells, and as we fill each, cells will be filled one at a time, and then a temporary cover will be placed over it before moving along to the next cell. So there will only be one cell kind of open to the elements at a time. We have a leachate collection system in the engineered containment mound. that will collect leachate, and it's going to bring it back to this white building, which is our wastewater treatment plant. So all the leachate that could come in contact with the waste will be treated and then will be discharged through one of two routes. We have a exfiltration gallery that will discharge back to ground, or if the water table is too high, we'll be discharging directly into Perch Lake. We have a number of support facilities like an admin building and that kind of stuff, change rooms and those kinds of support things that we'll need for the facility. And then there's 3 stormwater management ponds. This is for clean water that's being diverted off the site during construction and operation. So 3 different ponds here. And so that's the basic features of the NSDF. So now I'll get into the meat of today. There we go. So today's presentation, I'll just start off by explaining what the Environmental Assessment Follow-up Monitoring Program is. We'll give a bit of an overview of our current monitoring that we do at the Chalk River site, with specific emphasis on, of course, the effluent monitoring. And then I'll explain specifically what we're going to be doing for the near surface disposal facility effluent program. Now, before we get into that, there's a number of acronyms, and I want to make sure you guys can follow along because sometimes we flip back and forth between acronyms. I'll try to say the whole word every time, but NSDF is Near Surface Disposal Facility. The EAFMP is the Environmental Assessment Follow-up Monitoring Program. And the EVMP is the Effluent Verification Monitoring Program, and that's the topic we're here to discuss today. So what is the program about? What are we proposing to do? So what is the EAFMP? So it is proposed to monitor the NSDF project activities to verify predictions in the EIS, to ensure that mitigation measures are performing as expected, to identify any unanticipated effects, and to look to limit any unanticipated effects if they are identified. There are basically 4 components to the EAFMP. There's the effluent monitoring, there's the environmental monitoring, there's the groundwater monitoring, and there's a 4th component that we call operation control monitoring. And operation control monitoring is monitoring that really just doesn't fit into those other categories. Stuff like visual inspections for dust and confirming integrity of turtle fencing doesn't really fit into those other categories, but are still important monitoring aspects that we want to include in the EAFMP. So I will cover one of those operation control monitoring activities related to, that is more closely related to effluent in this presentation today. In future presentations, there'll be other discussions on some of the other operation control monitoring. It's important to note that this EAFMP is currently in draft. We will be incorporating feedback that we're going to gain from these types of stakeholder engagement. Also, we'll be doing Indigenous engagement, and we'll be looking for your feedback to look at many revisions that might be needed for the program. And it will be finalized following a decision from the CNSC. So we base the EAFMP on a number of different requirements. Of course, because this EA is being conducted under the Canadian Environmental Assessment Act 2012, the EAFMP will follow the rules and the guidance under that act. There's also guidance in the Canadian Nuclear Safety Commission has a reg doc called 2.9.1, which is environmental principles, assessments, and protection measures. And again, there's some guidance in there about what should be included in the EAFMP and how it should be conducted. We do have our company-wide program requirements for our effluent verification, environmental monitoring, groundwater monitoring program. So we have a number of internal documents and standards on how to design and implement those types of programs. And those designs are all based on the CSA standards that are in place. There's a suite of CSA standards, and the one that's more pertinent here is N28.5, which is effluent monitoring programs at Class 1 nuclear facilities and uranium mines and mills. And I apologize, I have to wave my arm because the light went out. Ooh. I'm in a conference room and the light just randomly went out because I haven't moved for a while. So sorry about that.
Christine, 1 second. Christine, can you just move the microphone away a little bit down? Yeah,
Yep.
yeah, perfect.
Okay.
Thank you. Thank you.
All right. So the monitoring for the near surface disposal facility will be similar to our existing site-wide monitoring program that we already have here at Chalk River. So I just want to give you a bit of an overview of what we currently do in our monitoring program so you can have an idea of what that looks like. So we have an environmental protection program here on our site. The mandate of our program is to ensure that all personnel are practicing responsible environmental management, that we are ensuring that all of our regulatory compliance activities, all of our activities are in compliance with our regulatory requirements, and that we are supporting the implementation of our environmental policy. We've got a number of different focus areas here. We have an environmental management system that is registered to ISO 14001. We do have a significant focus on sustainability. We set sustainability objectives and targets in a number of areas to continually improve our program. We want to make sure we understand our environmental compliance obligations and are implementing those appropriately. We have Effluent, environmental and groundwater monitoring programs here at our site. We have a biodiversity monitoring and management program as well. And we do human health and environmental risk assessments. So we have what we call an integrated environmental monitoring program. And the reason it's integrated is because, you know, some of the aspects of our 3 different monitoring programs do overlap. We will track the fates of contaminants through the different phases of the environment as they travel from the atmosphere to the biosphere to the geosphere. We'll do this in an integrated fashion. So this picture is just a demonstration of that type of the type of monitoring that we do. So from a facility, one of the main release points might be to atmosphere. So we're going to monitor effluents from air through our air monitoring. And then we look at, you know, atmospheric deposition. So we'll look in the nearby communities or around our site to see what kind of atmospheric deposition we're getting from our from contaminants that may have been released from our site. We'll also look at the nearby communities to see what kind of impact there might be to foodstuff like produce. We look at fish and game as well. We look at farm animals and those types of things. We also monitor obviously liquid effluents from our site. And of course, they'll go into the Ottawa River and we'll monitor downstream at the drinking water plants at Petawawa and Pembroke. Also in the river, the fish, of course, I've already mentioned. And then of course, we'll monitor groundwater, which around some of the waste management areas. And we also have perimeter monitoring that's right along the riverfront to look at any contaminants that might be coming through in groundwater. We'll look at where it comes to surface water on our site and monitor those particular locations, and then track those contaminants as it makes its way through the environment on our site and then eventually off to the Ottawa River. So we do this in an integrated fashion to try to make sure that we've got we can track contaminants through all phases. As I mentioned before, the programs are designed in accordance with CSA standards. So under the Effluent program, it's CSA N28.5, which I mentioned. So here we monitor effluents from about more than 60 roof vents and stacks on our site. And then we monitor 15 liquid discharge locations. For our environmental program, we conduct this under the CSA N28.4, which is environmental monitoring for Class 1 nuclear facilities. We'll monitor air, surface water, farm animals, garden vegetables, fish, wild game, beach sand, and atmospheric deposition from more than 100 locations, both on our site and off of our site. And for groundwater, Again, that's conducted under the CSA N288.7, which is groundwater protection and monitoring programs for Class 1 nuclear facilities. We monitor more than 190 different wells that are along the riverfront and along the perimeter of our operating areas. And those are conducted semi-annually. So our monitoring programs, we do have goals and objectives that are specified for our effluent verification monitoring program. So our overall goal, of course, is to monitor and evaluate the quality of our airborne and waterborne effluents released from the Chalk River property. We want to verify that those effluent quality remains below our regulatory limits, that we're confirming the adequacy of controls that we have in place on effluents, to detect changes in effluent quality that could be indicative of unusual or unforeseen conditions, and obviously take action if we need to in those areas, and then also to provide data for assessment of human and ecological health. So in our program documentation, we have specified some triggers for when we would have effluent verification monitoring and when it would be required on a particular site. So these triggers are listed here, and we want to, one of the triggers would be if environmental risk assessment indicated a potential concern in a particular area or a particular parameter. If we needed to be able to identify any unplanned releases from a particular facility, we might have some effluent monitoring. If the monitoring is required to support a risk assessment, so sometimes we'll do baseline monitoring or that kind of thing, or assess some areas in order to update our environmental risk assessment. And then for other business reasons, could be stakeholder concerns or due diligence as an example. So what does the monitoring look like? So for those of you who are not familiar with our site, so we have obviously the Ottawa River here. This is the site, the fence that goes along with the Petawawa base, and it kind of goes down here, and the site is actually much bigger than what we have here, but I wanted to show a bit of a close-up of some of our monitoring locations. So on this map, you'll see that there are light blue dots, and they represent our radiological air monitoring locations. The dark blue dots represent some of our liquid monitoring, and we do both radiological and non-radiological monitoring in our liquids. What's not shown on this map, we also do non-radiological monitoring in air, but it's kind of a diverse set of criteria that we're looking at. So we do monitor greenhouse gases, and we monitor some of the criteria air contaminants that are specified under the National Pollutant Release Inventory. So those are things like nitrous oxides and sulfur dioxide and particulate matters. The other thing we look at is road dust emissions. And so these emissions are obviously around the site because they're based on burning of fuel either in vehicles or stationary diesel generators and that types of things, or it could be natural gas used to heat buildings and those kinds of things. So that's why they're not shown here on this map. But I wanted to mention that because it's important, because of course we're going to be doing some of that with the NSDF. But just to give you a little bit of lay of the land here, so there is some air effluent monitoring that is done around some of our waste management areas. And then we look at some liquid effluents here. These are into Masquinage Lake because that's one pathway to get to the Ottawa River. And they also have another effluent point here, which is on Perch Creek, which basically drains this kind of area and drains where the NSDF will be. Giving a little bit of closer up on our built up area. This is where most of our buildings and facilities are. So you can see that we do monitor a wide number of airborne roof vents and stacks on our site here. We have the NRU stack, which is shown out here, and then a number of liquid discharges to the Ottawa River. So just some other details about our monitoring program. We have been here for a long time. We have a lot of data. We've been operating for more than 60 years. Every year we collect 5,000 samples and we do about 20,000 analysis every year on those samples. For the radiological air emissions, we do continuous monitoring of our roof vents and stacks. We also do continuous monitoring of our process type liquid effluent discharges. So process, that would be like the process outfall, the sewage treatment plant, those types of things. For both of these types of samples, they are collected on a designated frequency and then taken back to the lab for analysis. We do weekly or monthly sampling of some of the other natural streams and stormwater outfalls on the site. And the frequencies depend, of course, on the nature of the contaminants and the risks from that particular discharge. We do a broad suite of radiological and non-radiological parameters in our monitoring. We have a systematic data evaluation process. So every year we'll be looking for trends and comparing to limits and that type of stuff to do data evaluation. We also have a comprehensive QA/QC program to make sure that we've got quality data. On an annual basis, we're required to do a program review where we'll look for areas of improvement and changes that might be required to our programs based on changes of operations, issues that we might have seen in our QA/QC. And then we want to just verify that our program is still effective and appropriate and valid to the activities we have. And of course, annually, we are required to report this to the Canadian Nuclear Safety Commission. So we have an effluent verification monitoring report that goes out every year in April. So just to give you some ideas, obviously with the broad amount of data we have, I couldn't go through all of it. So I just picked a few of the highlights to talk about some of our results. So we have had numerous changes on our site over the last 3 to 4 or 5 years, and that's resulted in some really significant reductions in emissions in a number of areas. So just to show you here, we have our site-wide radiological air emissions. This is over the 2015 to 2020 timeframe. So in 2018, our isotope production shut down. So we had obviously significant reduction in emissions because NRU was not running anymore, and our moly production facility was also shut down. Down here on the bottom, this just shows our site-wide greenhouse gas emissions. These are estimated annually based on the fuel usage and some other factors that are specified in the greenhouse gas regulations. So we do these calculations annually, and in about 2017, 2018 timeframe, we switched our main fuel source at the powerhouse, which was our main contributor to greenhouse gas emissions. We switched from number 6 fuel oil to natural gas. So we realized about a 20% reduction in our greenhouse gas emissions with that switch, which is quite significant. That switch also reduced our sulfur dioxide and nitrous oxide emissions at the same time, which is fantastic. And then the other new thing we've done is a new sewage treatment plant came online in 2019. Our old sewage treatment plant used chlorine as a disinfectant. And so of course we would have chlorine releases into the Ottawa River. We've switched that over and now we use a UV disinfectant. So there are no more chlorine emissions from that site. So that's just a few of the things going on with our current effluent program. But before I move on and talk about the specifics of the NSDF program, I thought I'd pause here to see if anybody had any questions up to this point. And I see Ole Hendrickson has his hand up.
Yeah, thanks, Christine. I hope you can hear me. I'm interested in the liquid discharge monitoring locations for effluent verification. When I look at the NSDF final environmental impact statement, Perch Creek Weir is not even shown as a effluent monitoring location. You mentioned 15 locations.
Mhm.
There seems to be a real shortage of effluent verification monitoring in the Perch Creek Basin when it comes to liquid effluents. Why are there no Perch Creek upstream sources like the Spring B site? Why do we only have the Perch Creek Weir, and that one doesn't even show in the NSDF environmental impact statement? It just seems like there's a real shortage of liquid effluent verification monitoring in the Perch Creek Basin.
Sure, that's no problem. We do monitor those locations upstream of the Perch Creek Weir. So there's a number of them. There's the Perch Lake outlet. There's a couple of the inlets to Perch Lake that we do as well. There's the South Swamp and East Swamp, but those are under the environmental monitoring program because technically they're just not classified as effluents. They're classified as surface water and therefore are in the environmental monitoring program. If you attend our session next Tuesday, the environmental monitoring program will be presenting and you'll hear more about that. For the purposes of NSDF, and I'll get into the specifics about what's the NSDF effluent program looking like, Perch Creek isn't considered an effluent specifically to NSDF. That doesn't mean we're going to stop monitoring there. We obviously will because there's other reasons why it's considered an effluent in part of our program. We will continue that. It's just not considered an effluent for the purposes of NSDF.
Yeah, just to follow up quickly, Christine, if I may, I know that N288.5, the CSA effluent verification monitoring standard, remarks on how difficult it can be to determine whether to do environmental monitoring or effluent monitoring. It's almost a gray area, and you've explained that for the Perch Creek Basin, you've chosen not to do effluent verification monitoring, but instead to do environmental monitoring. However, would it not be more prudent to do effluent verification monitoring? Isn't that a little more rigorous, a little more QA, QC, and systematic? Why not switch over these environmental monitoring sites in the Perch Creek Basin and make them effluent? Because certainly there are effluents from waste management areas A and B. There'll be effluents from the NSDF if it's approved, from the liquid dispersal area. It seems like you're calling it environmental and saying it's surface water, but actually these are effluents coming from licensed facilities.
Yeah, I hear what you're saying. The QA QC that is applied to the environmental monitoring program is the same as what is applied to the effluent program. So there isn't that lack of quality on the data because we put it in one program or another. It's just how we've chosen to bin these things. The South Swamp Weir and East Swamp Weir, for instance, wouldn't meet the definition of effluent according to N288.5, which is why it did end up in the environmental monitoring program.
But surely the ones in Maskinonge are not. They're also downstream from the sources, from the plumes. So I just don't understand. But
so those are equivalent to Perch Creek is the final discharge from the Perch Lake Basin off our site. Those ones that we have in the Maskinonge Lake Basin are to look at the final discharge before it leaves our site. We could have picked a location further downstream, like Maskinonge Lake Outlet, but really by then it's way below detection limit and we don't really see anything. So that's why we moved them back a little bit so we could get something that maybe was detectable at those locations.
Well, I certainly wouldn't want to see you remove Perch Creek Weir from effluent verification monitoring for the NSDF.
No, and we wouldn't be.
Oh, okay. Thank you all. Good discussion there and some good feedback to note. Just checking in. I know some good questions from all. Is there any other questions before Christine moves on from from others. I'll check in to see if anyone else's hand is raised up. Okay, I'm not seeing anything.
Great. Okay. I'll continue on then. I mean, there will be more chances for questions at the end, so you won't miss your chance completely if you don't speak up now. So moving on. So I just already had this slide up earlier, but as we get into the specifics about what the NSDF EAFMP is going to look like, I just wanted to remind us of the objectives of that EAFMP. And that is to verify projections from the environmental impact statement and confirm that there's no significant adverse environmental effects due to NSDF activities, ensure the mitigation measures are performing as expected, looking to identify any anticipated effects and limiting those unanticipated effects if there are any identified. So how is this different from the CRL site-wide effluent verification monitoring program? So it's not much, there's not much different. You know, the environmental monitoring, the effluent verification monitoring for the NSDF will focus on verifying the results of the EIS and monitoring effluents from the NSDF specific project activities. Whereas from the CRL-wide effluent verification monitoring, we're looking at monitoring effluents from all CRL site-wide operations, and that will include the NSDF activities. So before we get into the specifics on what we're monitoring, it's important to understand the activities that are occurring during each phase of the project, because as we move from one phase of the project to the other and the activities change, that'll dictate what we need to monitor and where we need to monitor those things. So just to give an overview of what's happening in each phase. So during construction, we will be obviously constructing the engineering containment mound, the liner, the perimeter berm, and all of the systems that go along with that. We'll be developing the surface water management infrastructure, on-site roads and site access type infrastructure, and we'll be constructing the wastewater treatment plant, our effluent transfer systems, all the support facilities, and all the site infrastructure. So lots of construction activities, lots of things going on. During operation, I mentioned that the cells will be filled in phases. So there'll be this phased development of the disposal cells. There'll be the actual placement of the low-level waste into the engineering containment mound. As cells are filled, we'll have progressive closure of the disposal cells and installation of a temporary and the final covers. And then the operation of the wastewater treatment plant and the discharge of that treated effluent. Those will all be happening in the operations phase. During the closure phase, we'll be installing any remaining components of the final cover for the engineering containment mound. We'll be decommissioning the infrastructure and support facilities. The wastewater treatment plant and surface water management systems will be done kind of last and right at final closure, and remediating and grading of the NSDF site. And then post-closure, we're just going to be doing some surveillance and inspection activities to verify the integrity of the facility for as long as is necessary. So then, as we get into the monitoring objectives, so similar to our site-wide program, we have objectives for the effluent verification monitoring program for the NSDF. These have been broken down by the environmental components, or the environmental discipline, or what we call value components. So under the area of atmospheric environments, the objectives there are to verify the predictions in the EIS with respect to dust emissions to ensure that they are reasonable and conservative, and verify that methane and other greenhouse gas emissions rates that have been estimated are also reasonable and conservative. And those activities will be happening during construction, operation, and closure. Under the surface water environment and aquatic environments, we'll be verifying that the surface water management ponds are performing as designed. We'll be verifying the water quality of the effluent from the surface water management ponds, And we'll be demonstrating compliance with our effluent discharge targets. Those are our objectives. And again, during constructions, operations, and closure. And in the area of ambient radioactivity and ecological health, again, verifying predictions of the EIS with respect to dust emissions to ensure that they are reasonable and conservative, and verifying treated effluent from the wastewater treatment plant and ensuring that it meets discharge targets. And just a reminder, the EIS, according to the environmental impact statement, there was no predicted significant adverse environmental effects from NSDF in any of these environmental disciplines. So then what does that actually look like when we get into what are the details of what we're going to monitor? So under site preparation construction, we're going to be estimating dust from travel on unpaved roads, material handling, grading, blasting, stockpiling, all those kinds of activities that are going to generate lots of dust. We'll be estimating greenhouse gas emissions from mobile and stationary equipment. We'll be estimating the NPRI contaminants from the mobile and stationary equipment. And we'll be monitoring our stormwater runoff and sediment from construction and the non-operational areas. During our operations phase, we've got all of those same 4 components that I just mentioned. But here we'll be adding on estimating our landfill gas emissions from the waste decomposition in the engineered containment mount. We'll be estimating greenhouse gas emissions from the wastewater treatment and support facilities. Obviously, these facilities will be heated with some sort of heating fluid, probably propane or natural gas. And so there will be greenhouse gas emissions from that. We'll be monitoring the wastewater treatment plant effluent quality. We'll be monitoring the stormwater management ponds effluent quality, and we'll be monitoring for any potential halocarbon releases. That's from air conditioning systems that we might have in the buildings. The monitoring during closure phase is going to look actually very similar to that as in operations. Of course, right at the end of the closure phase, when we do shut down the wastewater treatment plant, that will be moving away. And in post-closure, the last thing that we've monitored is stormwater effluent quality. So then what does that look like in terms of locations and things we're going to be doing at the actual site? So for the airborne effluent streams, there's going to be obviously the variety of areas on the NSDF site, as I mentioned, when we're looking at dust and greenhouse gas emissions from mobile equipment and stationary equipment. It's going to be in a variety of areas on the site as we're conducting our work. We'll be monitoring the engineering containment mount cover for greenhouse gases, volatile organic compounds from the vents as the waste is decomposing. And then also from whatever support facilities and other buildings that have air conditioning systems, if there is any leaks of halocarbons, we need to track and report those as well. So all of these things are done on an annual basis. And I say they're estimated because there is formulas in place on how to calculate greenhouse gas emissions, dust, NPRI, and all of these things in all of the regulations that we will follow to come up with these estimates. So the next thing we'll be monitoring, obviously, is our wastewater treatment plant. So the wastewater treatment plant has been designed to treat all the waste, all the liquids that could be collected from NSDF, and ensure that they can treat it to the discharge targets that are protective of human health and the environment. So, we'll be monitoring the effluent from the holding tanks once it's been treated. We'll be monitoring for a variety of physical, radiological, and non-radiological contaminants. Obviously, we're comparing them to effluent discharge targets, and we'll be doing that prior to discharge. So there will be a batch discharge, but we'll be verifying that everything has been cleaned up appropriately before it's discharged. Here, I should just mention again that we do have 2 potential discharge locations for the effluent. So the wastewater treatment plant's up here, and we have this exfiltration gallery, which is a engineered area in the ground that'll help to diffuse the water back into the groundwater to make sure that we're not depleting the groundwater tables in this location. But sometimes in the spring, the water table can be rather high in this area. And if we find it is too high and it can't take the treated effluent, we will be using this line down to Perch Lake, and we'll be discharging there. So the other areas that we'll be monitoring, surface water management ponds. There are 3 surface water management ponds located around the facility. We'll be monitoring for flow. We'll be monitoring physical, radiological, and non-radiological contaminants as well. So how often will we be doing that? We'll be doing that through each storm event. So every time there's a storm, we'll make sure we have a specific schedule for monitoring. And then 3 times a year following the first year of construction. And people go, why 3 times a year? So it's the ice-free times of year. So we could say quarterly, but it's likely going to be iced up. So we'll only be able to get 3 samples per year. And then the last thing, operation control monitoring that we'll be doing with the stormwater management ponds. To verify that the stormwater management ponds are performing as designed. And it will be done at all 3 ponds. We'll be looking at water levels and sediment depth. And again, this is just to make sure that the ponds are performing as they were expected to perform. Monitoring again throughout each storm event. During construction, we'll monitor them annually, and we'll also monitor 3 times a year following the first year of construction. So now that we have done all of this monitoring, the question is, what are we going to do with the data, right? So we've set up a two-tier system for data evaluation. The first tier is comparing the results either to the baseline conditions or the predicted concentrations from the EIS. The second tier will compare to a number of other benchmarks and limits depending on the effluent stream and the parameter in question. It'll depend on which comparator we choose. But it could be environmental benchmarks or release limits, provincial air quality guidelines, guidelines for the protection of aquatic animals, drinking water guidelines, or DRLs. Those would be some of the things we might use to compare to. And so then the next step in the process is to look at what do we do if we exceed one of these limits? So again, if we exceed tier 1, we'll look at some resampling to confirm that exceedance. We'll do some trend evaluation to see if previous samples showed kind of an increasing trend or whatnot. We'll investigate the source of the exceedance, and we'll also consider increasing monitoring frequency if that's deemed appropriate. If we exceed any of the tier 2 criteria, again, doing that data review, looking at trends and resampling to confirm exceedance is going to be definitely the first step. Investigating the source of the exceedance. We'll be applying additional mitigation measures if that's applicable. We'll consider stop work if that's applicable. And we'll increase the monitoring frequency as required. So that might include increased frequency, additional parameters, or maybe additional locations to help confirm what we're seeing. The next step, of course, is then to do our reporting of the EAFMP. So as we get results, we'll be obviously doing analysis as the results are coming in, looking for those exceedances and looking for actions that we might need to take based on those. And then annually, we'll be reporting to the Canadian Nuclear Safety Commission per the requirements of our License Condition Handbook. So we are required already to provide an effluent monitoring report, which goes out every April. We have an integrated environmental monitoring report, which comes out at the end of June. And there's a requirement to report on EA follow-up monitoring, and that will come out in July. It's important to note that as we verify the predictions in the EA and move through the EAFMP, the size of that follow-up monitoring report will diminish as those predictions are confirmed. We'll be moving from calling it follow-up monitoring to just having it in the effluent monitoring report. But for the first several years of construction and operations, it will be in all three reports. So the last thing we do is similar to our regular program. We'll do continuous improvement of the AFMP through a number of different mechanisms. Obviously, we'll be doing assessment of the data from a day-to-day basis and looking at trends and implementing any adaptive management measures that we need to put in place. Annually, we'll be looking at kind of larger trends from year to year and determine if any changes might be required to our programs based on what we're seeing there. For instance, if we see maybe increasing trend in an area, we might institute a special investigation based on those trends. And then we also do this full program review, which looks at our full program design to ensure that it is still adequate and effective in meeting our objectives. So based on that, we could result in increases in monitoring where we need to. We could also have decreases in monitoring where we find it's no longer necessary because we've met our objectives or whatnot. Anyways, in summary, just wanted to mention a couple of key highlights. So, we've aligned this environmental assessment follow-up monitoring program with the appropriate CSA standards. We will be reporting these results to the CNSC in a number of different areas. We are looking to continually improve our program and respond to changing conditions as necessary. This is a draft. It's currently available on the website, our CNL website. So please make sure that you have a copy of it. We welcome your feedback on the CFMP. That is the purpose of today's meeting. That is the purpose of all of these engagement activities we are doing. And the CAFMP will not be made final until we've taken into consideration some of the feedback we're receiving, and also until the CNSC has made a decision on NSDF. And that is all I have for today. So we can open it back up for questions again. Mitch?
Yes. Thanks, Christine, for the presentation and all the information. I know it's a bit to dive into, and also for reminding everyone that this is available on our website for review as well. So thank you for that. Oh, I see that that Ole has his hand up, so that's good. Thank you, Ole. I'll open it up and encourage others to also get involved if they have questions. But thanks, Ole, for starting us off.
Sure, no problem, Mitch. There are references in the NSDF EIS to untreated effluent, and that would be the leachate from the mound prior to its treatment in the wastewater treatment plant. In order to document the performance of that plant, and in the event that of a potential release of untreated effluent, it would be very prudent to include untreated effluent in the effluent verification monitoring program. And I think that can be very easily done by sampling from the holding tanks that would be constructed for times when there might be a larger generation of leachate, and it's necessary to store that leachate prior to treatment. So I'm asking if that has been given some consideration to monitoring and reporting on the untreated effluent from the mound.
I can take this question or comment, so thanks for that. Monitoring of our incoming effluent in the tank is part of the plan. So it's not necessarily linked to the effluent monitoring program. It's more linked to ensuring that as the effluent goes through the wastewater treatment plant, we're using the ion exchange columns. And we want to make sure that we have those set up properly so that we can meet our effluent discharge targets. It's certainly something that we can consider including in the results of the annual monitoring report so that you can see what the parameters were incoming and then outgoing as well. So thanks for that.
Thanks, Sandra, and thanks all for getting us started. Hopefully that's given some others some time to think about some questions or comments they may want to make. Just looking. Oh, I see Ol wants to continue the conversation. So Ol, and I'll encourage others to get in here, please, as well.
Yeah,
Thank you, Ol.
I just to keep things going here. Sandra, you did a good job, I think, talking about the pathways, but maybe a little less on what parameters to measure in effluent. And I guess I'm looking at N288.5, the CSA standard for effluent monitoring programs, and looking at, there's a couple tables in there. Table 7.1 talks about nuclear or hazardous substances typically monitored in airborne effluents, and then table 7.2 is for waterborne effluents. So when I look at the airborne effluents, there are 5 different categories for facility types like nuclear power plants and fuel fabrication, particle accelerators, uranium mine and mill. And it's a very good list of the actual parameters such as tritium oxide, carbon-14, noble gases, particulates, radioiodines, gross alpha and gross beta, and also non-radioactive hazardous things like arsenic. And when I look at these lists, it strikes me that the waste that would go in the NSDF would be a mixture of the waste that would come from a nuclear power plant and from a uranium mine or mill, particularly given the large quantities of material that were shipped up in the 70s from Port Hope and put in Waste Management Area F. So I would think that when you list, and I think you very much should list the actual parameters that would be measured as part of the effluent verification monitoring, that you include both the category nuclear power plant and the category uranium mine and mill from tables 7.1 and 7.2 in CSA standard and 288.5. Thank you.
So yeah, I can talk about that. So the emissions that might come off the engineer containment mound, while technically that might be an effluent, it would be impossible to monitor that as an effluent because of the diffuse nature of those emissions. We are, as part of the environmental monitoring program, going to be monitoring around the in the dominant wind directions. We've got some high volume air samplers to look at particulates. We've got some other monitors to look at gamma, and we'll have tritium, carbon-14, and those kinds of things set up in the dominant wind directions from the NSDF to look at what was released from the mound and traveled those distances. But it's not, it would be impossible to include those as an effluent in the engineering containment mound because there's no one single location you can pick to do that monitoring. It's not like it's funneling through a ventilation stack, which we can put a monitor on. Does that make sense?
Well, when I look at N288.5, it actually does talk about those high volume air samplers as an option. And I think certainly for worker protection when we're thinking of things like tritium and radon, and also the dust. Dust can be sampled it doesn't have to be estimated. There are optical samplers and yes, no sampling program is going to be perfect, but those are definitely what I think N288.5 would consider to be effluents, those air emissions like dust, carbon-14, tritium, radon, and so forth. So I really think serious consideration should be given to including those in an effluent verification monitoring program.
Yeah, I think you'll see if you come next week, you'll see those things covered in the EMP part of the environmental monitoring program, which we could use to back calculate what the emission effluents would be. But yes, I think you'll see that it's there, but we'll just double check to make sure that yes, it is all there.
And I hope you will look at N288.5 and those tables 7.1 and 7.2 and actually make a description of the parameters, not just the sort of pathways, but discuss in more detail when you construct this program what actual parameters will be measured.
Yeah, and that is there. So there's tables in our EAFMP that outline which streams we'll monitor and why we monitor them and what kinds of things we expect there. But then further down, we look then at each effluent stream and look at what parameters we'll be monitoring and why we're monitoring which parameters. So I think it's there, and we have a similar format for the environmental monitoring program as well, which will show where we monitor, why we're monitoring at that location, and then what things we're monitoring, what parameters we'll be looking at.
Okay, thanks all for the great feedback and the discussion. I think all great things to consider, and for us to help us better maybe articulate some of the things that you've mentioned here today. Opening it up to the rest of the audience, is there any other questions or comments that would like to be made? It's becoming the old.
I was
yes.
hoping others would weigh in, Mitch. I'm sorry, but I think this is an interesting one.
It's fine.
It has to do with the exfiltration gallery and the times of year that it may or may not be in operation. And I know sometimes we get, really hard, crusty, frozen surface to the snow pack. And if you try to spread water, I suppose warm water would maybe melt and sort of just sink into the snowpack. But I'm wondering if how much the issue of frozen soils might be a problem for release of effluent into the exfiltration gallery.
Sandra's coming on to answer that one.
I think we're trying to figure out who can maybe answer this one. So just give us a second here. I don't know, Martin.
Sure thing.
Martin, maybe you can pipe up. Martin, you're still on mute. I see you. Oh, there we go.
Sorry, took a moment. Yeah, thanks for the question. Only, so the exfiltration gallery is below grade, and it will be discharging water below grade into the unfrozen region. One thing we will be doing is we will be monitoring the water table elevation continuously in the immediate proximity to the exfiltration gallery. And under spring conditions, if the water table is high and near to the surface, then we will not be discharging to the exfiltration because there's a risk of flooding at this location. And under those conditions, the effluent will be transferred to Perch Lake.
The only thing I'll add to that is that we aren't doing continuous discharging from the NSDF wastewater treatment plant. So the effluent will be stored and sampled. I think Christine mentioned that prior to discharge. So we also will have some capability to hold effluent prior to discharge. So if there were conditions that weren't favorable, we have lots of storage to just store it until we can discharge.
Okay, thank you. And thank you all for continuing to keep the conversation going here. I'll once again open it up to the audience to see if there's any other comments or questions. Oh, we have all again. So all ask away.
Yeah, just to keep things going here, another thought about the exfiltration gallery is that, of course, at least some of the hazardous and radioactive substances in the treated effluent will gradually build up over time, and some will be more strongly retained on soil exchange sites and organic matter and so forth. Others will migrate through the soil more readily, like say strontium 90, which we know is already has migrated from the waste management areas in the Perch Creek Basin. So what are the plans to monitor the gradual buildup of radioactive and hazardous substances in the immediate vicinity of the exfiltration gallery?
All right, I'll give the team a second to figure out who can best answer this.
Martin's going to take this one, Mitch.
Yeah. So we will be monitoring groundwater up gradient and immediately down gradient of the exfiltration gallery at a number of locations. So that's the monitoring we will be doing. We will not, at this point, there aren't plans to monitor buildup of contaminants on soil, but the concentration in groundwater would certainly be indicative of what concentration, if any, buildup there is on the soil.
Thanks, Martin. So I see we have about 20 minutes left here, roughly, I think. And I know Ol's been asking the majority of the questions and has given a lot of time for others to think and maybe posit some things that they might be interested in asking about or commenting on. So again, I'll open it up and see if there is any other questions from the audience. Okay. Well, maybe if I'll give sort of the wrap up here, and as I'm doing this, if there's other questions, please feel free to put your hand up. But I will point out, and Christine's made reference to this, and I think some of the questions that Ole has been asking are going to hopefully, Ole, you can come to the next sort of sessions where we get into more detail on some of these things. But so the next sessions will be held on Tuesday, October 5th. That's the environmental monitoring one. And then there's another on Thursday, October 7th on the groundwater monitoring. And same process as this one, registration required. If you do have a question or anything to do with any of our projects, as I said off the top, any additional questions that you think of after this can be emailed to ermstakeholder@cnl.ca. Be happy to get you a written answer, or if it's more helpful, give you a call and have a discussion with you as well. So happy to do that. So that's the logistics at the end here, and when we're going to be next out with these. So we hope that you're able to attend those. So as I was doing that, was there any more questions or comments that anyone else had? Okay, well, thank you very much for your time today, for tuning in and learning about this particular aspect of CNL and the NSDF project. Ole, do appreciate you leading the discussion at the end there with some of your questions. Very helpful, and we do appreciate that. So thank you very much in particular. And we do hope that you can attend the other sessions. If you're not able to, as I mentioned off the top, we do record these sessions and they will be made available. So you can tune in, have a listen. If you have questions, again, you can email us at the email address below. Okay. Thank you very much, everybody. Have a good afternoon, and we'll see
Thank
you at the
you.
next one.